All right, and here we go with reflection. So reflection is actually really not that bad at all. Sometimes the rules get a little bit hard to define, but when it's simple, like just going across an axis, that is not bad at all. Well, I'm going to do something here to start. First, I'm going to make a line because blue is kind of like a mirror. So there's my mirror line, straight up and down there. It's going to go across this. What that tells me then is I can go, so I'm like in a lighter color here, so from B to this, how far is that? Well, that's 2 units, so I'm going to go 2 units over here. The other one's like purple here. Let's say I want to do this P, that's 4 units. Well, then that's going to go 4 units over here. We're just duplicating or reflecting onto the other side. So now let's do some would work just fine. So B was here, now it's there. P was here, now it's there. Similarly, this A is going to go on this other side. Now L is already right on the line, so that's just going to stay. So now if I connect the dots for all my new pieces, I get this reflection. And it looks so symmetrical. It's a perfect mirror image. And how did I know I was going this way specifically? Well, it said y-axis. Now let's look at this next one. Again, a mirror line. So here's my mirror line that I'm going to be going across. So I'm going to do this one a little more freehand this time. It looks like this is 3 units, so I'm going to go 3 units over here to E prime, you could say. And here we have another 3 units, so that's going to go 3 units again to U prime. D is the long one, so we got 1, 2, 3, 4, 5. So we're going to go 1, 2, 3, 4, 5, all the way out to here, to D prime. And then there is our reflected image. Perfect reflection. Same distance on both sides. That's really what matters, that those are the same. All right, let's jump ahead a little bit now. So some of these are going to be a little bit different. Let's try, for example, like this one, reflect across the x-axis. So when we're reflecting across the x-axis, now here's our mirror line going across the middle. This is our mirror. So if we're going to go across the middle, this K that's 2 points away is now going to become here. This R, which is 1, 2, 3, 4 points away, is going to go down to -4 there. And N, since it's already in the middle, just kind of stays there. It kind of replants itself right on the axis. So then we kind of put these together, and we got our symmetry again. No problem. All right, now here's a really interesting one. Check this out. It says reflection across the x-axis. So I'm going to draw a mirror line in there. I'm going to make it fairly straight here too. So here's my mirror line. And, well, this is kind of weird. It's like I have things on both sides of the mirror. Okay, then in this case, this y, which is 2 units away here, is going to go 2 units away there. So that y is now there. So this is y prime. M, on the other hand, is 3 units away, and it's going to go all the way down here to 3 units. And there's M. And they still both connect to K. That's not any different. So it has this weird, almost like spinny thing, where the top went down to the bottom, and the bottom went down to the top, and the middle stayed in the middle. So when you reflect, but your mirror line is going right through your shape, it looks more like it just spun around like a top. So it's kind of interesting. Sometimes there's reflections on both sides. You get a reflection going across one way and the other way. Very interesting stuff there. All right, let's get to something a little more advanced. Like this. Let's do 44, for example. It says reflect across x equals -1. So if I were to throw a line in here at x equals -1, there's a couple of things that we need to keep in mind. The first is that x equals -1 would be a vertical line. So this right here is a vertical line. That means that x equals -1 would be right Okay, now do some freehand work. We're going to see how far each of these points are. So V is only 1 unit there, so V prime is going to be 1 unit here. D is 2 units here, so it's going to be D prime, 2 units right there. W happens to be 1, 2, 3, so it's going to be 1, 2, 3. Now I can connect those with some straight lines. So there's 1, there's 2, and there's 3. A perfect reflection. Now this was kind of different because in some of the other ones you simply just kind of change the values to negative, like the x's would become negative or positive. But here the numbers are totally different for each one. For example, right here, x equals negative 3, negative 3. But over here, x is negative 1. And there's symmetry, except the negative 3 and the negative 1 don't really balance because the line isn't really centered. So when that line isn't centered, these numbers differ in a different, it's just not the same kind of like one's negative, one's positive. They're actually different numbers as well. So let's see if we can do another one of those, but maybe like in the y-axis. Ooh, no, here's a rule. This is a great one. So if I wanted to kind of figure out what the rule was, I need to figure out where the middle is. So if I'm looking at this, I can tell that those two connect and these two connect. So then middle, I just need to find the middle point. Well, this total thing here that's 6 units. So that means that each piece is 3 and 3, so the middle would be there. And similarly, the middle would be here. So that gives me my mirror line. So there's my mirror. So all that I need to say then, once I know where the mirror is, it's going to be a reflect across, and in this case, it's the x-axis. Let's see if we can find one that's just slightly more complex than that, but the same idea. All these are pretty easy. Oh, here we go. How about 56? 56 is kind of interesting. So on 56, I can visually tell, like, okay, so between these two x's, that would be the middle. And between these two l's, that would be the middle. So we got a mirror line. Whoa, that's a little bit off there. Let's redraw that. Let's redraw that. We got a mirror line straight down right there. Now that mirror line isn't on an axis, but it is on an x value. It's right here, right there, and that's at x equals 1. So we're going to reflect across x equals 1. Piece of cake. All right, now some of these other ones where they twist on themselves, those are kind of interesting too, because it's like the letters overlap and you can't even read the letters. But you can kind of tell where the middle is, because let's say there's the W's, here's the H's, so the middle would be right there. Now if I were to count and figure out where this is, we got negative 1, negative 2, negative 3. So right there, it's that x equals negative 3. So we would say that we're going to be reflecting across or about or around x equals negative 3. Piece of cake. This is so easy. It's really just about drawing and catching stuff with your eyes. So let's see. Now the last ones. This, I gotta say, this is the craziest one ever. So we're going to do a diagonal. A diagonal translation. We'll finish with this one right here. So a diagonal translation, y equals negative x. That's a diagonal line, and it's just 45 degrees, kind of perfectly like that. So I'm going to go directly across this whole thing, right through the middle. There's my mirror line. So this is my mirror line right there. Now, for me to go across, I can kind of do these diagonal units where it's like a combination of one in each direction. So I go one diagonally here. That would put me one diagonally right there where the new M is. And for this F, if I'm going diagonally, it looks like I'm going 1, 2, 3 diagonally. So I'm going to do another 1, 2, 3 diagonally here. And I would get f prime. So this is m prime and f prime. Now for the s, we got 1, 2, and a half. So that's like a half, 1, and 2. So there's the s. And then the c, we got 1, 2, 3 and a half. So I'm going to go a half, 1, 2, and a 3. And there we go. There's the new shape. Now there's a numerical way to check this as well, and it's actually based on this right there. Negative x, or x, y equals negative x, or we could have said x equals negative y. So look at this f here. It's at 1, 2, 3, 4. So it's at negative 4 and 1, 2. So that'd be negative 2. The inverse of that, we're going to make them both positive and switch them. So negative 4, negative 2 is going to change into 2, 4. Both positive. And that's exactly where this f is. And that's kind of the pattern or the rule that you would have gotten. You could have said x, y turns into negative y, negative x. It's like they swapped places and made them negative. Very cool. Very, very cool. All right, so we're going to end on that one. Great job. Go back, take another look at it, and just try to take your time. You don't need to rush these because it's good to document all the different points and all the different steps.